right? So my question was design the subtractor. So subtraction means you need to subtract from one bit to the relevant value. So this is the 2 bits. So 0 minus 0 will be give 0, and 1 minus 0 will give 1, and 1 minus 1 will give 0. What is the answer for 0 minus 1? So what is the answer? You need to find out. Please raise your hand. Anyone? Yes, Harsi, only one. But there is a problem, right? You can say 1, but there should be a difference, no? 0 minus 1. Let's consider our goal is, let's say, 1 1 0. No. 0 1. We need to reduce 1 1. So what is 1 0 1? It's 1 4 1 2 4. So 1 0 1 is 5. 1 1 is 3. So 5 minus 3 will be given 2. So 2 means 1 0, right? Again, the departing got 1 0 1 can 5. Because if I can 2 9. අඩු කිරීමනේ. ඒතර මහා අඩු කිරීම 3. එන්නෝනේ 1 0. Right? So as I mentioned, 1 1 is 0 and 0 1. We can get this one. Right? The answer is correct, but only half. So what will happen to this one? So we are reducing 1 1 0 0 minus 1. So let's consider in a decimal way. Let's say 15 අඩු කරනවා. So what will happen? So let's consider the first one. We are subtracting 3 from 15. So 5 minus 3 is 2, and we are taking this one. So it is 12. Right? Let's take this is 25. So it has to be 22. Right? But let's take, we are reducing 8. So 5 minus 8, we can't do that. So we need to take one, we need to borrow one from here. So then this will be 1. So then the value will be 50. So 15 minus 8 will be 7. Right? And we have this one. So answer is 70. Right? So we need to borrow some. Right? So in here also, so this is grade 2 mathematics. In here also 1 minus 1 is 0. We cannot reduce 0 and 1. We need to borrow 1 from here. Then 1 0 minus 1. 1 0 minus 1 is 1. Right? So there is another bit called borrow bit. So this is called borrow bit. And it is 1. Right? So when we are designing the truth table for this one, so what are our inputs? We have two inputs and we have two outputs. This is one output and this is one output. So A, B, 0, 0, 1, 1, 0, 1, 0, 1. And this is the subtraction, the value is up and for 0 minus 0. 0 minus 0 is 0 and sub borrow is also 0. 0 minus 1. So subtraction will be 1 and we need to borrow this one. So this is our output. 1 minus 0 is 0. Sorry, it's 1. Sorry. And borrow is 0 and 1 1 is 0 and this is also 0, right? And we need to design design the logic circuit, right? So what is this gate? It is XOR gate, right? And the problem is this should be an AND gate, but something is different, right? 0 and 1. So this is A bar B. Right? Since it is only the one, we need to take A bar. A bar and B. Is the subtraction, this is called. Right? So in this way, you can decide the half subtractor. And as is in the previous knowledge that we had done, design the full end. You can draw the full subtractor space. Right, we design this half adder. So as I mentioned, combinational logic circuits, the output will only depends on the present input. And this is the half adder. So this is the circuit. And to design full adder, you need to design this this truth table. So we have designed that as well. So and this is the full adder circuit, right? So full adder, there is need two half adders. Um, this carry Everything. Nice. So this is the full letter, right? So we have drawn this as well in last week. So there are three inputs, A, B, and carry in, and two outputs, sum and carry out, right? So by looking at this input and output, we can drive draw a block diagram. So there are three inputs, A, B, and C in, and two outputs. So those are sum and C out. This is bullet. So our header only had two. B and A. This is our head. Right. So this is the logic circuit for full adder. So in full adder, it is the half head. So there are two half heads. Right. And by looking at only the inputs and outputs, we can draw a block diagram. So after there are only two inputs, A and B, and two outputs, sum and carry. So in full letter there are three inputs, A, B, and carry, and two outputs, sum and carry out. So only we consider this only circuit. What we can do is we can like say 1 1 0. So we need to add this one, right? 0 1 plus 1 is 1. 0 and 1 1 is 0, and we need to add 1. 1 1 1 will be 1 and 1. 1 1 is 0 and 1. So this is the final output, right? 0 and 1 1. 1 1 is 0, and it will pass another one. So 1 1 is 1 and 1 is 1 1. So this one and this one will pass to here. So it is carry out. So this 1 1 will be 0 again, and there is another carry out, and this one will be this. So 1 0 1 0 1. This is the answer for this problem, right? But we can only do this part and this part using a half adder. using a full adder, right? So here also this bit is 0. We can only do that 2 parts, but we need to do this whole thing, right? So there are 1, 2, 3, 4, 4 bits. 4 bits. Here also 4 bits. Here 1, 2, 3, 4, 5. There are 5 outputs, right? So we need to decide that circuit, like how to do this whole calculation through and logic circuit, through a logic circuit. So how we can do that? Right. So let's consider our problem again. So it's 1, 1, 1, 1, 0, 1, 0, 1. Right. 0, 1. And this is the problem. So did you aware by only considering so we into summation of these two. So our initial part. So first the binary point will only have 2 inputs maximum, right? And apart from that, there can be 3 inputs in this one. There can be 3 inputs, right? Only these two has only 2 inputs, right? මේ initial point එකේ මේ binary point එකේ තියෙන inputs දෙක. ඒක identify කරගන්න පුළුවන් නේද? Please raise your hand if you didn't understand anything. Initial step එකේ තියෙන inputs දෙකයි outputs දෙකක් තියෙන්න පුළුවන්, right? In the on the now I'm drawing this block diagram, right? Adder. So there are only 2 inputs, right? So consider this is X and this is Y. So here this one is X0 and this Y0, X1, Y1 likewise. This is 1, 2, 3. X3, Y3, right? So X0 and Y0. This is our first output, 1. Right? 1. And if let's consider this, there is a 1 here also. Then 1, 1, it is 0, output is 0, and there will be a carry forward, right? So in that case, there should be a carry forward bit as well. So let's take it is C0. C0. I say C1 because that carry forward bit is for here. So that means this one is C1, right? Consider this is correct. This is X1, Y1. This will be a full ladder because there is an input for here as well. And this is the output for 2. Is it correct for this location? Zero, 1, 0, 1, 1, 1, 0, 1, 1, 1. Right? This is X, this is Y. So this is this X1 and Y1. X1, Y1. And there can be another input from this one. So that is C1. Right? So this output is C2. You get that? That means we are passing this to here. And from this one again, this will be a full ladder since there is to be a 3 input. X2, Y2. O0. So O0, O1, O2, C3, X3, Y3, O3. Full ladder. And since there is only 4 bits we need, 1, 2, 3, 4, this is the final output, 4, 5. So this is O1, O2, 3, O4, O5. So in this circuit, you can see we can add any 4 bits values. The other interesting thing is even we can replace this initial half ladder using a full ladder also. So there should be another carry in bit. So it is C0. So what that means is here. So this C0 is always 0. So we can derive this 4-bit binary addition by using 4 full ladder circuits. So so these are the block diagrams. So this whole circuit will be represented as the ripple carrier. This whole circuit is known as the ripple carrier, where you can add 4 bits. So the advantages is we can say up to the n number. So here let's say it's On. Likewise, we can maximize this to any number of xn, yn, on, on plus 1. We can maximize up to n number of digits. So we can add actually any number, any binary value by using this triple period. So please raise your hand if I need to explain it again. Make I explain current one. Right. So what you need to understand is here in this half adder, you can add only two bits, 0 and 1. Right? 0 and 1, 0, 0, 0, 1, 1, 0, 1. In this full adder, you can add something like 1, 1, 1. Likewise, 3 bits, and there will be only two outputs, sum and carry out. Right? So by sequentially put these full adders as this format, you can add any number of bits. So these x0 and y0 will be consider this is x and this is y, and these are will be x0, y0, x1, y1 likewise, and the carry forward bit will represent as e1. Right? And the output will be represented in this visit. Right? So you may aware. So for a full ladder, there are several circuits. Two XOR gate and two AND gate and one OR gate. So there are several gates inside this full ladder to do this mathematical calculation, right? And so I have explained about the half subtractor. So you can decide the full subtractor, and even you can further increase it to something like ripple carry subtractor to subtract any number and by using logic gates. The theorem is simple. You first usually identify the concept and draw the truth table and identify the gates are inside and then design the whole circuit. So this is the full ladder, and we just now create the triple carry adder. So this is 4-bit. So that means there we can some 4-bit binary values by using this adder circuit. And you can even replace the initial half adder using a full adder as well. So in that here the Cin will be always 0. So next one is the decoder. So as mentioned here, select the memory location according to binary value placed on the address line in the memory bus. So in decoder, what you need to understand is this n should be the power of 2. So there is n number of inputs. There are 2 to the power n number of outputs. There are decoder. There are a number of inputs. There should be 2 to the power n number of outputs. Right? So how you can design that decoder? That means there are x, y. That means two. There should be four outputs. So if there are x, y variable, there should be four. So if x, y is it, how many output there should be? 2 to the power n is 8. There should be 8 outputs, right? And as mentioned in the code, in the code, the presentation slide. So decoder, that means like there is a binary value, and it is only allow one. So let's consider only one a. So then a is only one variable. So n will be 1. So 2 to the power n will be 2. So there is 2. There should be 2. Step A and B. There should be 4. Right? That's the theorem. And according to this variable, let's say this is 0, then this should work. All others should be false. And if this is 1, consider this is 1. If it is 1, then this line will work. Likewise, there are 0, 0, 1, 1, 0, 1, 0, 1. If those are 0, 0, this line will work. Say A1. If this is 0, 1, then this should only work. It is A3, then only this one. It is both 1, 1, then only allow this one. Right? Did you understand the concept? So there are 2 inputs and there should be 4 outputs. And according to the binary values given into this, out of that 4, only one line will be active in that time. So how we can draw a truth table for this decoder? කොහොමද මේකට truth table එක හදන්නේ? Anyone? අර idea එකක් තියෙනවද? Let's go. Consider x, y. So 0, 0, 0, 1, 1, 0, 1, 1. Right? So if it is 0, 0, then this should work. 0, 1, this should work. 1, 1. Right? It is something like this. You understand? That means in every occasion, the whole occasion also there should be an output. So in this occasion also there should be an output, right? One the if you have any questions, please ask in the middle. This line A, line B. And this is a symbol. Right. So A, this is A bar, and B, this is B bar. So what actually gives A, B, say A bar and B bar. B bar and B bar. And so this is A bar, B bar. Right. So next one A bar and B. Likewise, A B bar. A, right. There are two inputs, A and B. There are four outputs. And if this is A is 0 and B is 0, this will active. This line will active. Right? If A is 0, B is 1, then this gate will active. This is 0, 0, this is 0, 1. Likewise, this is for 1, 0, this is 1. Only a particular line will active in a given Boolean given values, there will be only one line going to active. So that's what will happen in decoder. Right? In decoder, according to the given values, we can identify what is the line that will going to active. right? So it mentioned here. So other thing is the multiplexer. The multiplexer has the same kind of thing, but their differentiation is if there are 4 inputs and there is a only there will be only one output, right? There are not so much outputs, only one output, but there are some control lines. And if there are 2 control lines, that means there are 4 outputs, 4 inputs. If there are only one control line, that means there are only 2 inputs. However, there will be only one output in a multiplexer. So it means it does the opposite of the decoder. So that means select single output from a several inputs. That means there are so much inputs and it will only select one uh, input according to the control line. So that means if there are end inputs, that means 4 inputs, log to power n control lines are needed. So log for O is 2, right? So what that means there are 4 inputs. 4 inputs log 2 to the power n number of inputs are there. So log 2 to the power n is, so n is here 4. Log 2 to the power 4 is 2. Right. So yeah, we can use the same one. That's right. So the A and B. Right. This is A, B. Then B bar. B bar, B bar. Right. So A bar, B. power above, right? And in multiplexer, the opposite will happen, right? So as I mentioned, there are control lines, and in decoder, if there are any inputs, they are to the power n. So in multiplexer, if there are n control lines, there are to the power n inputs, right? So what that means is, if there are uh, two inputs, two control lines, there are 2 to the power n number of inputs, right? There should be 4 inputs, right? And only one input will active for given control line. What that means, this one, 6, 2, 3 is 4. So then what will be the answer? This is AB, I1, AB bar, I2, A bar B, I3, A bar B bar I4. Did you get that? So we can connect this one with this input. So what will happen is, if control line gives 0, 0, 0, 0, that means this one. This will only active. And consider this always are true, since we need to get information from a particular line. Consider this is active, then we'll pass only the value of this I4. Did you get that? And if this is let's say 1, 0, so this then AB bar. So AB bar is I2. Only I2 will be active, right? Likewise. Then, as I mentioned, the multiplexer only has one output. So output will be the summation of these 4 control lines. So summation will be an OR gate. This is the there are 2 control lines. Say there's a AB and there are 4 inputs. And according to that, if these are 0, 0, then I4 will only active. Then output will be I2. Otherwise, this all becomes 0. So all becomes 0. Then all the thing will become 0. If this is 1, then this is 1. A bar B bar is 1. Blah blah is 1. 1 plus I4 will be I4. Right? So that is what will happen in multiplexer. So I have did this one. So I just draw the circuit. So ALU So what is the LU as you know? Please put into the chat uh, what is the LU mean? Please put into the chat what is the ALU mean. Anyone, please? So what is the ALU? Look at the ALU again. Yeah, arithmetic and logical unit. So when you are doing program, what are the those arithmetic uh, functions you learn, like summation, multiplication, right? There are several operators you have learned, right? So we know how to design the circuit for the summation essay. So there is a block diagram. So output will be this. So this in this is actually the block diagram for all summation. So inside this circuit, it has triple carry adders, which designed by using full adders, and there are several other operators as well. So many number, even bitwise operators or likewise many number of operators are there, right? So those will come from the data buses, right? Then these are A and B, right? So we are passing A and B values to these ones, and we are getting output, right? So this will output A plus B. Will output A minus B. This is A multiplication B, right? But this is actually what will happen in ALU. But we only, let's say we need only the one particular output, even the summation or something one particular output. So that means mark switch. So this output will comes to this multiplexer. Right? There will be only one output. So according to these inputs, there are control lines, right? There are some control lines. So according to that, it will give the relevant output that we are requesting from the ALU. So it will exactly select one output from our given ALU. Right? So let's consider A is passing 15, B is passing say 12. Right? So it will comes to all these values. So let's say B is 2, BC. So A plus B will be 17, 30, and 30. Right? But we only need the this one summation. Right? So it will decide by using the those control line, what will is the output will be, let's say, operator. So control lines will identify what is the operator. So operator here is zeroth operator, right? And it will give the output. So output will be only active this line. This line will only active, so output will be 70. But however, it will going to calculate all the things. That's what happened in the system. Yeah, right. Actually, we can decide to stop to other ones as well using demultiplexer and all. And so at the moment, you can decide the way how this ALU is working. It's not have any magics. There are only logic circuits, and they are to some precision so as to aware let's say in 16-bit value, they need to have full ladder, 16 full ladders. So in a simple full ladder, there are number of circuits and gates, two AND gates, two NOR gates, two XOR gates, and one OR gate, right? So in the simply identify a gate, there are so much like capacitors and transistors. So much of electronic tools are needed to do this stuff. So those so everything is packed in that ALU. But the theory is Very easy. Right. So here is this ALU, and you need to only add these two AB, and you there is a selection line to derive what is the operator need to do. So in this case, this is 0, and we will only get the output 7. Right. So this will happen in right. So in this operator, it will have consists of triple carry address. This is a subtraction operator, multiplication. Likewise, bitwise operators are there. So many operators can be designed by using these logic gates. So I have any questions up to now? Students? Okay, since there are less number of participation, yeah, I will stop this here and share. So from next week, I will conclude the final part of the tutorial sessions, that is sequential circuits. There are sequential circuits. It will basically for creating the memory. So now you do how to do those arithmetic operations using the present inputs, and present inputs are only depend on the output will only depend on the present inputs. But in memory, the output is depend on the present input as well as the previous output as well. So in there, you will need to know about this clock, and there's a message. Multiplexer again. Sure. So please give me a few time to give us some introduction to the sequential circuit. So as I mentioned earlier, combinational circuits will only depend on the present input, but in sequential circuits will depend both present input and the previous output, right? So that means the sum of the output will going to put it as the input. So there are several circuits you need to find that those are flip-flop. So here we will teach you about this flip-flop, and you need to know how to do this timing diagram and JK flip-flop and binary counter. Yeah, D flip-flop and register. So this will be the final part. So I will do in next week. Right. So multiplexer. So what I'm asking you to is please try to draw this diagram and see. Then it will be easy to you to understand. So multiplexer. So as I mentioned in decoder has n inputs and 2n outputs, and but at a one occasion it will only allow one input to follow. That again inputs p2 n ගානක් තියෙනවා කියලා 2 to the power n number of outputs තියෙනවා. ඒ කියන්නේ එකක් තිබුණොත් outputs දෙකයි. දෙකක් තිබුණොත් outputs 4යි. තුනක් තිබුණොත් outputs 8යි. හැබැයි but it will only allow one line. That means even there are 2 to the power n number of outputs, only active, only true, only one line at a given time. ඒ කියන්නේ line දෙකක් input line දෙකක් නම් output සතරක් තිබ්බට එක මොහොතක true වෙන්නේ ඒ කියන්නේ එක මොහොතක active වෙන්නේ එක line එකක් විතරයි. Right? So all other lines will be zero. That will happen in decoder. Right? How we are going to do is by using to both A and A bar, B and B bar. So we are using those gates and here draw the circuit. You can find out. So there will be an output in every occasion, but it will true only one occasion, right? But in multiplexer, the theory is something bit different, right? It, it will always have only one output in a kite, but there are control lines. And control lines and inputs have the relationship. If that means if there are one control line, then that means there will be only two inputs. If there are two control lines, then that means there will be only four inputs. We cannot increase or decrease. There should be four input lines if there are two control lines, right? හැබැයි output එකෙන් දෙන්නේ එන input වලින් එක answer එකක් විතරයි. කියන්නේ it will give only one input as an output. ඒ කියන්නේ input එකම මේක output එකක් වෙනවා. ඔයාලට මතක නම් මම draw කරලා ඇඳපු එක දැන් මේ this consider this diagram. So our inputs are I1, I0, I1, I2, I3, right? හැබැයි මේකෙදි අපිට එක මොහොතක අපිට එන්නේ එක්ක I1, I0, I1, I2, I3. If we consider a particular time, there will be only one output. Either it's I0, I1, I2, or I3. Right? Exactly that one. Not going to zeros or others. In decoder, you find out the other output will be zero. Only one output will be true. But here, there will be only one output, and that will give exact the particular input. That means we are going to select particular input from a given number of inputs, right? So how we are going to do this? Using the same technique. So in selection lines, we can select a particular line, right? And for that particular line, we are passing the relevant information as well. So that what that means is, let's consider this one. So it has S0 bar and S1 bar and I0. So if this both S0 and S1 bar is both true, then what is the output? The output will be I0, right? So other outputs will go into zero. If you draw the truth table and see, or just pass the information, that means this both are zero. Then this is zero means this is one. This is zero means this one bar is one. Then the output is I0. Here, this is one, and this is zero. So AND gate, if there is only one zero, it is zero. Here, in this one, this is zero. In this circuit, the both are zero, right? So all the others are zero, and what is the output here? I0 plus 4 zeros, right? 3 zeros. So I0 plus 3 zeros means so 3 zeros, it will be I0. right? Likewise, it will give only one output. So please draw these diagrams and see, then you can easily understand. Okay, students, do you have any more questions? Please design these circuits. You need to design the subtractor by yourself. Please design it by yourself. And there are so much videos also to learn about this, all these. And to this multiplexer, to for decoder, right? And what is ALU, how it consists. Then next week I will go through about these flip-flops and all. Right. If you have any questions, you can ask. Otherwise, we can wind up the session.